Hello, good day. My name is Amusa Kende Abraham Adishola, and my topic for my research method coursework is using data science to forecast and optimize energy consumption in London. My report explores how data science can help forecast and optimize energy consumption in London because London is a city facing rising energy demands due to rapid urbanization, with the UK targeting net zero emission by 2050. There's a need for smarter and real-time forecasting tools that goes beyond traditional models by using machine learning and real-world data for smart metrics, building and weather patterns, so we can predict energy usage more accurately and reduce peak demands. The study also considers ethical concerns like data privacy and equitable access. And overall, my dissertation, which I'll be aiming to support both technical innovation and urban policies, helping London move towards a cleaner, smarter, and more sustainable energy system. During my literature review, properly reviewing well articulated and recent articles really shaped my approach towards viewing my dissertation in general and my ideology. The literature review covers both technical and ethical dimensions relating to my topic and my research objectives. Models like Prophet, LSTM, and XG have shown strong results in predicting energy trends, and these are supported by clustering techniques like K-means, to which allows us to group users' behavior to know the affected users and the relation to the energy trends. And this model often operates in silos and don't account for legal or ethical concerns. So studies also highlight that while stock modeling tools like 3D stocks provide insights in building energy performance, they don't support real-time forecasting. At the same time, macro economic models used in government planning are too broad to address borrow level variation. So, what's missing is an integrated approach, one that combines forecasting and optimization with LSEPI, legal, social, ethical, and professional issues. That's the unique contribution my work is aiming for. It's technically robust, but also mindful of fairness, equity, and policy relevance. So my research aim is to investigate how data science techniques can be used to forecast energy consumption patterns and optimize energy distribution in London. And also, some of the objective is to explore the applicability of machine learning algorithms for forecasting energy consumption on a time basis, hourly, daily, and monthly, and also to identify the and analyze the key determinants of energy consumption in London, and also to assess how data science models can be applied to optimize energy distribution and reduce peak loads and improve grid responsiveness in London. So my methodology is quantitative and data driven. For forecasting, we will be using Prophet for trend decomposition, LSTM for capturing temporal dependency, and XG Boost for its high accuracy on structured data. For segmentation, I will be using K-means to uh, group household based on usage, and these models will be evaluated with RMSE and MAE. The data comes from trusted public source, so I'll be getting my data from trusted public source like the UK Power Networks and the London Data Store, and the forecasting model will help predict future loads, while optimization methods will simulate how the grid might respond to different demand scenarios. This includes demand shifting, load fluttering, and real-time allocation. Ethical approval is also being sought, and data is fully anonymized. This combination of real world data, predictive power, and ethical responsibility ensures academic rigor and practical application. I will be using secondary data sets for my dissertation from sources like UK Power Networks, Low Carbon London Project, and UCL's 3D stock model. Data includes smart metrics reading, building characteristics, and demographics factors. The data is cleaned using Python and Panda and merged into a single analytic framework. And analysis includes time series forecasting and multivariate correlation to understand what drives energy usage. And I'm also applying dimensionality reduction to simplify the feature set and improve model performance. This process ensures the model are both interpretable and efficient. So for visualization, I'll be using tools like Matplots, Seaborn, and Plotly will be used to help visualize temporal patterns, user clusters, and peak loads. So because visualization plays a critical role in communicating my findings to stakeholders, so I'll create energy heat maps, consumption timelines, and bar plots to illustrate impact of social economy and environmental variables. I'll also explore the use of interactive dashboards to help stakeholders like the policymakers or and urban planners to engage directly with the data forecast. These visual tools are essential for turning raw prediction into actionable insights. So the image in this slide shows my Gantt chart, which breaks down my report into distinctive phases, which ensure that each phase receive appropriate focus and helps me complete my report in time. Given the project complexity, risk management is crucial. I was able to identify five possible major risk categories related to my topic and related to my objective. So, such as accessing data, the model performance, ethical compliance, and time management, and also the scope creep. For example, if LSTM becomes too computationally heavy, I will switch to Prophet. And ethical concerns are being mitigated by only using anonymized public available data and ensure GDPR compliance. And time risks is also addressed through weekly progress tracking. And I have also kept my scope focused. This structured risk strategy ensures the project stays on track. And writing this project has been both challenging rewarding. It pushed me to think more critically, question my initial assumptions, and also recognize how much I have grown academically. One of the biggest turning points was realizing that energy forecasting isn't just a technical task, it has real ethical and social implications. While I started with purely technical focus, I soon began integrating legal, social, ethical, and professional issues into the foundation of my research. That shift changed how I structured my objective. And shaped the entire direction of the project. I'm particularly proud of clearly defining my project problem, the research problem, and narrowing the scope. Something that's difficult in such a wild field like data science. I initially tried to take on too much, but thoroughly reflecting and feedback, I refined my focus to something both realistic and meaningful. Looking ahead, I plan to start modeling development alongside with writing my chapter 3 pretty soon. This parallel approach will help me grow my analysis in real results rather than just theory. Overall, this phase has not only laid a foundation for my dissertation, but has also helped me grow into a more thoughtful and responsible researcher. All the insights in this report are supported by academic sources. I followed the Harvard references style throughout the report, and this reference ensures the study is grounded in credible and current and relevant research. Thank you, and my name remains Amusa Kende Ibrahim Adishola.